Hi students, this is Mr. Yao. Today we're going to talk about 4.6 where we learn how to solve an equation by completing the squares. First part, we are going to talk about how to solve an equation by taking square roots. And before we do that, let's review something we have learned before. Let's review how to simplify square roots. First, 72, square root of 72. We are going to draw a factor tree. So 2, then 36, then 2, then 18, and 2, 9, 3, and 3. So square root of 72 is square root of 2 times 2 times 2 times 3 times 3. Now we're going to take out pairs. That's a pair, so 2. That's a pair, so 3. And we still have this 2 left inside, a 2. So we're going to get 6 square root of 2. And to be more precise, when we actually try to simplify or solve it, we need a plus minus as well in the front. Okay, next, square root of 625. 5, 125, 5, 25, and then 5 and 5. So we're going to get square root of 5 times 5 times 5 times 5. And we count by pairs, that's a pair. So 5 outside, that's another pair. We don't have anything left inside, so we don't need a square root anymore. And it's going to be 25. Again, preferably you actually write it as plus minus because they both work. Next, square root of negative 686. Before we do anything else, we see a negative sign. That's going to be square root of negative 1 times square root of 686. I'm going to do factory on 686. That's 2, then 3, 43, then 7, and then 49, then 7, and another 7. So it's going to be square root of 2 times 7 times 7 times 7. We have a pair of 7, take it out. Then we still have 2 and 7 left inside, 14. But do not forget, we have this in the front. Square root of negative 1 is actually an I. And since this part still gives us plus minus, so we need plus minus in the front. That's what we have learned in Unit 2. If you're struggling with it, please go back and review. Now let's talk about how do we get rid of the square. When we want to get rid of the square, we are going to take square roots because that's the opposite operation. Just like when we want to get rid of division, we need to multiply. When we want to get rid of addition, we need subtract. So square root property. If x squared equals a, then we actually have x equals square root of a or x equals square root of negative square root of a. We can also write it as x equals plus minus square root of a. That's including both. Now let's have a look at some examples. Example 1, x squared is 9, and here's how we actually show that. We're going to take square root on both sides, that's how we write it, and that is going to be cancelled with the square, so we have x equals plus minus 3. Don't forget the plus minus because they both work. Next, x squared equals negative 40, so we're going to take square root on both sides. And in that case, if you want to remind yourself, also put plus minus right there so that you know the answer has plus minus. X equals, we're going to actually need to take the factor tree of 40. So 2, 20, 2, and 2, 5. And that is going to give us a pair of number right there. So it's 2 square root of 10. But this negative number right there, that's going to give us an I. So it's going to be plus minus 2 square root of 10. Next, example 3. This time, we do need to move things around. So that's kind of the process of solving these equations by taking the square roots. We need to make sure square is the only thing left on the left side. So in this case, we are going to minus 5 on both sides. So we have 10x squared equals 80. Then we're going to divide both sides by the 10. We got x squared equals 8. Now it's time to take square root. Plus minus. So x equals, if we do factor tree on 8, it's 2, 4, 2, 2. Clearly have a pair of numbers right there. So it's going to be a 2 outside, another 2 inside, but do not forget the plus minus in the front. That's example 3. Example 4, we're going to need to move the 50 to the right side, so we only have square left. Add 50 on both sides. So we got x minus 2 squared equals 50. I'm going to square root both sides because besides square, we don't have anything left on the left side. Plus minus. So that means x minus 2 equals, we're going to need to do a factor tree on 50. So 50, 2, 25, 5, and 5. We have a pair number, which is 5. So 5, and then we still have square root of 2. Don't forget it's plus minus. So next, you might actually want to separate them, or you can think no matter what I have on the right side, when I want to solve it, I just need to add 2 on both sides. So my final answer, x equals plus minus 5 square root of 2 plus 2. That basically means one of our answer is 5 square root of 2 plus 2. Another answer is negative 5 square root of 2 plus 2. And that is both of the answers for example 4. Now let's keep going. Example 5. So that's a special question now, because the left side we don't see just square, and we cannot get rid of the 10x to move to the right side. But gladly, we can actually factor it so that we can end up with a square on the left side. So if we do 25 and then 10, we're going to end up with 5 and 5, x. So clearly the left side is actually x plus 5 squared equals negative 49. Next, we are going to square root both sides. So the square root gone plus minus. Don't forget we have a negative right there. So we're going to end up with x plus 5 equals square root of negative 1 is an I, square root of 49 is a 7, and plus minus. And then now we're going to need to subtract 5 on both sides. So we end up with x equals negative 5 plus minus 7, 5. I'm just trying to also write it in the standard form for complex number. So the regular number, the real number goes in the front, the I goes to the back. Example 6. We're going to do the same thing. Factor the left side first. So we got 9 and negative 6. The number we need is negative 3 and negative 3. X on the top. We're going to end up with x minus 3, then squared equals 32. Now, in order to get rid of the square, we're going to square root both sides, put plus minus. So x minus 3, when we do 32, 2, 16, 2, 8, 2, 4, 2, 2. We have one pair of 2s, two pair of 2s with an extra. So it's going to be 4 square root of 2 plus minus. And now we need to move the 3 to the right side by adding 3. So x equals 3 plus minus 4 square root of 2. That's example 6. Example 7. This time, same thing. We are going to factor the left side. 4 times 25 is 100 on the top, 20 on the bottom. The combination we need is 10 and 10. Then we have 4x on the top, 4x on the top. They can both be simplified to be 2x over 5. That is also 2x over 5. So the left side is 2x plus 5 squared equals 8. Solve it the same way, square root both sides. Square root plus minus. So 2x plus 5 equals plus minus. Simplify square root of 8. So we have 8, 2, 4, 2, 2. The pair of number we have is their 2's. So we're going to be 2 square root of 2. Now we're just going to solve it this regular way, but things might be slightly different. So first, we're going to subtract 5 on both sides. So we got 2x equals negative 5 plus minus 2 square root of 2. And then we're going to need to divide by 2 on both sides. Divided by 2. So we got an x equals 2, then negative 5 on the top, plus minus 2 square root of 2. You can choose to simplify it and write it as negative 5 over 2, then plus minus the 2 square root over 2 over 2 is going to be just the square root of 2. So you can separate the fractions and then simplify it, but just don't forget the plus minus. That's example 7. Example 8. We're going to do our cross method. So it's going to be 9 times 4, 36. On the top, negative 12 on the bottom. And then the combination we need is negative 6 and negative 6. 9x on the top. That can be simplified to be 3x over negative 2. Left side as well. We have 3x minus 2, that squared equals 50. Going to square root of both sides. That is gone. Square root plus minus. 3x minus 2 equals plus minus. When we try to simplify 50, square root of 50, that's going to give us 5 square root of 2. We're going to add 2 on both sides. So 3x equals 2 plus minus 5 square root of 2. And then we are going to divide both sides by 3. So our final answer, x equals 2 plus minus 5 square root of 2 over 3. Again, don't forget the plus minus. Next, I'm going to talk about 2 examples from 4.5. They do involve something that we just learned in 4.6. So in 4.5, example 6. This question, we actually need to factor by grouping first. So that's going to be 3x squared being taken out. So divided by 3x squared, we're going to have x minus 5 left, plus 2 x minus 5 as well, equals 0. When we see x minus 5, we have x minus 5, add up to x minus 5 times 3x squared plus 2 equals 0. And we can see the first one, x equals 5. But for the second one, 3x squared plus 2 equals 0. When we try to solve that, we're going to end up with complex number. Let's still solve it. Minus 2 on both sides. So we got 3x squared equals negative 2. Then we're going to need to divide both sides by 3. So we have x squared equals negative 2 over 3. Now we are going to need to square root both sides, plus minus. So this is the tricky thing. We're dealing with square root of 2 over 3. So x equals, let's find a place to write that on the bottom. We're going to have x equals plus minus. We already know this little negative sign is going to become I on the end. So we just have square root of 2 over 3. And if you want to deal with square root of 2 over 3, it's the same as square root of 2 over square root of 3. So we're going to have top and bottom multiplied by square root of 3 to simplify. That's going to give us square root of 6 over 3. So final answer, x equals plus minus square root of 6 over 3i. That is the answer for number 6. And number 8 in 4.5, we're going to factor it. That's going to give us x squared minus 9, then x squared plus 4 equals 0. And since it's perfect square, we're going to have x plus 3 times x minus 3, then times x squared plus 4 equals 0. First one, that's going to give us x plus 3 equals 0, minus 3, x equals negative 3. X minus 3 equals 0, plus 3, that's going to give us x equals a positive 3. Next, x squared plus 4 equals 0, minus 4, x squared equals negative 4. We are going to need to square root both sides. So x equals, that has a negative sign, so it's going to be an I on the end, so plus minus 2i. And all of these are final answers that we need to circle. For example 6, if you want to circle your final answer, these are your final answers. That is everything for the first part of 4.6. Thank you.